He is the VP for the Small Cell Forum, and here he is. All right, come on up.
Great, thank you, Jennifer. Yeah, let's go ahead and make sure that Patrick, Luke, and where's our other? Derek. Yep, hey Derek. Are wired up. I think, did you, yeah, so just we've got late regrets from Luke. Really want to invite everybody in. This is going to be an extremely exciting panel discussion. This is great, a great point in the day. So we've been talking about small cells. We've been talking a little bit about Wi-Fi. We've been talking about DAS. We've been talking about indoor deployments. And this is a really nice time to kind of pull it all together in a panel discussion. So we've got a small cell expert. We've got a DAS expert. We've got a Wi-Fi expert. We've got some crossover. We've got a lot of deployment experience. So I want to make this interactive. I've got a couple of questions we're going to get through at the beginning. And then we're going to open it up for you guys to ask your stumpiest questions you can think of. Try to stump the moderator or stump the panelists. I'll just give it to the, it's easy for me, right? Just give it to them. But yes, we have Patrick Lau. He's the Director of Business Development for CommScope. And then we also have Derek Peterson, who's the Chief Technical Officer for Boingo Wireless. So let's go through the panelists and let you guys introduce yourselves. Start with Derek.
Okay. Good afternoon, everyone. So I'm Derek Peterson. I'm the, as I said, Chief Technology Officer for Boingo Wireless. A lot of people know us for Wi-Fi, of course, since we've been doing Wi-Fi since 2001. It started off as an aggregator, but then back in about 2006, we ended up owning and operating both Wi-Fi networks as well as DAS networks. We have things like the World Trade Center, Lincoln and Holland tunnels, and a lot of DAS networks in a lot of the different airports and stadiums. So we're continuing to grow there, and we're starting, of course, like everybody, to start to deploy small cell networks. You know, our big thing is going into venues and helping venues deploy whatever connectivity that they need to be successful in the venue, and that's kind of our main focus.
Great. How many people have heard of Boingo Wireless before?
Okay, good.
Makes you feel pretty good, right?
That does
feel
good.
Just want to get off on a
How
positive
many
note
people
here.
do we get DAS? That's another question.
How many people have ever used a Boingo Wi-Fi network before?
A lot less than we get DAS.
Okay, let's hear from Patrick Lau from CommScope. Tell us a little bit about yourself and your company, what you guys do.
Thank you, Andy. Good afternoon, everyone. Patrick Lau here. I work for CommScope, legacy Andrew Wireless, and what I do for the company is for our in-building and small cell solutions. I work in a group called the Coverage Capacity Solutions for the Distributed Coverage Capacity Solutions. I work out of here. I've been in the industry for about 18, 19 years. Ironically, it's all about DAS. I was thinking about it the other day. That's how long the DAS has been. And I know some people here probably in the audience and has been in the industry longer than I have, but DAS really has gone through a long way, but that explains a little bit what I do. It's the pre-sales activities, and I'm responsible for the North America region, for all the new opportunities and looking for the new vertical markets. We've been talking about it from different panels and the presenters, talking about DAS has become a mainstream, talking about certain verticals. And I do see the shift in the different verticals to different sets of the vertical applications. So we can talk about that later today.
Great. Well, please join me in welcoming our esteemed panelists here. So the first question to the panel for 500, Alex, is DAS versus small cell. Where's Mike? He sneaked out of the room already because he had that chart in there. You know, one of those, that was a good one, right? The big Muhammad Ali chart. So DAS versus small cell, choosing the right technology. So we're going to hand that over to Patrick. Patrick's got a lot of experience in DAS, and then I'll take the small cell piece of that. So go ahead,
Great.
Patrick.
Thank you, Andy. Again, we're talking about DAS. DAS has been around for a long time, and if you talk to some of the industry veterans, DAS has been around since the late 80s, and really until recent has become mainstream, probably 5 or 7 years ago, because all the main large high-profile the public venues, talking about the airports and the sports venues and the stadiums. And small cell has really become popular in the last, also in recent years, 5, 7 years, is because since the deployment of 3G and 4G network. And I think our position, we look at it, is not really a one-size-fits-all solutions for all the different applications, because each solution has its own pros and cons, and at the end of the day, it really depends on the applications that you're looking at. And I think some of the factors I would look at between when you're looking for a small cell or a DAS or different solutions is, number one, you're looking for the size of the venue. You want to see how large the venue is. And the second thing I probably want to look at is the venue for the population density, translating into your RF capacity, how many sectors you want it to cover. Some of the areas you want to talk about is how many different technologies you want to transport. It's 3G, 4G, you wanted something more, even legacy 2G or public safety. Or you wanted to see, you want to do a single carrier solution just to transmit a certain carrier or multiple carriers. And I think that these are the questions you ought to answer. In our, in my opinion, I think a DAS is more desirable, more fitted in the area to, in the areas of more mid-sized to large-sized the public venues, or the venues in general, that requires a high capacity, multi-carrier, multi-frequency, people call it infra-host, that type of environment. And I think there's sweet spots for DAS. And I think it's more cost-effective solutions for that application. Whereas for small cell, it's more fitted for small to medium-sized applications, perhaps 1 or 2 frequency bands or 1 or 2 technologies for single operators. And I think a lot of times it's not necessarily mutually exclusive between small cell and DAS. In some cases, we see using a small cell as an RF source to drive, as an RF source to drive the DAS. That happens as well. So I think at the end of the day, you got to look at what kind of application, and you can weigh in your own trade-off before you make that decision.
Great, thank you, Patrick. So yeah, from a small cell solution perspective, back we started small cell forum, and actually go to Derek next because we'll do a small cell versus Wi-Fi, right, Mike? That'll be fun too.
There's no versus, but
no, yeah, that's kind of what the conclusion we came to. Back in 2007, we started small cell forum, and we're going to CES. And we're thinking like, oh, Wi-Fi. They've only shipped 1 billion devices. We've shipped like 5. So it's how are we going to get like small cell versus Wi-Fi or small cell versus DAS? But kind of the conclusion we came to is it's really more of a toolkit. It's the right tool for the right job. What Patrick is saying, there's certain installations where DAS really makes a lot of sense, maybe in a large stadium environment. There's other installations, like an office building we saw from Spider Cloud Wireless, where it makes a lot of sense for a quick deployment in an office building, really good coverage. So there's definitely benefits for both technologies, pros and cons. Small cells really need to have quick deployment, good coverage. DAS, what I've heard from some of the operator members in the small cell forum is they like to use the DAS systems in large convention centers and large stadiums. But they're actually using small cells in those stadiums as well, maybe for the high-end, private boxes where they want to have good coverage in the executive box, like where Jerry Jones sits. You got to make sure he's got 5 bars and his whole 100 megabits for his dedicated cell in there. But it's really a right tool for the right job. And Derek, did you want to comment on that from a Wi-Fi perspective?
No, yeah. Well, let me comment on all of it. I think I'm going to be talking at 4 o'clock. I'm going to show you an example of what we did for Arizona State Universities. And when you look at what we've done there, it's all 3 of the above, and it's just recognizing that DAS, Wi-Fi, and small cells all together in that environment, in a university environment. You might want to put DAS at the stadium, and you want some outside DAS pointing outside some of the main venue areas or outside that stadium. And then inside some of the larger buildings where you have students going in and out constantly, they're snacking more, and so small cells makes sense there. But then sometimes when they're sitting around in the kiosk areas or certain areas around, you want to give them Wi-Fi so they can do their homework, they can watch their videos, and they can do the other things without affecting all the other mobile traffic that's going around there. And when we start looking at all 3 of these as working together, I think that's when we get to where we really need to be with building networks, which is, it's not DAS versus Wi-Fi versus small cells. It's what is the right thing for that specific location inside that specific larger ecosystem of the network. And I think that to me is the key, and that's how we need to start thinking about building networks, because we need all of it. I mean, the one thing we all know is we can't rely on one technology. We need all the technologies to be able to be successful.
That's a really good point. I think one of the operator speakers mentioned earlier today that they're putting Wi-Fi in the small cells that they're deploying. And there was a Sprint keynote this morning, because the incremental cost to have Wi-Fi in there is trivial compared to the overall cost of the site over the life cycle. So the second question that we're going to talk about today was analyzing the in-building vendor landscape. So we've seen a lot of really nice presentations from a number of different vendors today. We saw Spider Cloud Wireless on the small cell side. We saw the presentation from CSS and Solid more on the DAS side. But you guys want to comment a little bit about the vendor landscape, in-building vendor landscape? Maybe Patrick?
I'm a little biased because I'm in the vendor community here. Well, certainly, and I think the focus will be on the LTE. And LTE, as we know, it's interference-limited systems. So a lot of things, everything is about the interference. You want to design everything based on SINAR. And also LTE for the data demand, you add different capacities. There are so many ways you can add the capacities. You can either gain additional spectrum, where you can use a frequency reuse, or cell splitting, add in different sectors. And I think when you look at the design for the best practice, where vendors landscape, you look at these things. And for instance, for the DAS deployment, obviously you're looking for you split into more different sectors. And one of the things you want to maintain the high performance and quality of the SINAR, you want to control the frequency, the sector, to minimize the overlap between sectors. Those are the things from the equipment standpoint. And for one, there's a really couple. And I think from the equipment standpoint, you want to look for an equipment that can accommodate multiple carriers, multiple frequency, that sort of technologies, because it's more user-friendly for the installation purposes. You want it in one box per location versus multiple boxes in the location, especially in the larger venues. It's for the more cost-effective solutions, also installation cost perspective. And I think the other bit, you look at the equipment side, is because the LTE is an interference limited system. You want to use low PIM devices. Now for the DAS, the infrastructure of the DAS equipment, and one of the things that you have is you have the master, you have the remote, and from the remote you add it to the coaxial cable to the antennas. You want to make sure you use a very low PIM devices, passive devices from the remote to the antennas. The ones we have currently standards, I think, use -160 dBc. This is important. And I don't know what else you wanted to add.
No, that's good. Derek, do you want to comment on what you see from a Wi-Fi perspective on the in-building vendor landscape?
Yeah, I mean, I think that the key thing is that each vendor, whether it's the Wi-Fi, DAS, or small cells, have different strengths, and each location has different characteristics of different strengths required. An example would be we're standing up a bunch of military bases, right? So we're out there standing up these military bases. You go inside of one of these old buildings stood up to the military base, and they have, strong, very hard RF games you've got to play because they're very concrete, and you're trying to burst through the concrete and trying to get, the cells to deploy the cells in a way that you don't have these problems with RF. Whereas if you go to a stadium and it's a wide open space, there's different vendors who are better at that, and there are vendors who can have a really finely tuned channeled push to go through and burst through, some of the problems that you have at some of these different locations. So as far as I'm concerned, it's really about the best technology for that specific location or that job, and for that reason, I'm constantly evaluating new vendors and looking at the strengths that vendor has and evaluating against the other vendor for that specific type. So right now we deploy probably, as an operator, we deploy, the who's who of vendors, and we continue to look at it.
Right. Yeah, it's quite a healthy ecosystem on the Wi-Fi side with over 1 billion chipsets shipped. I guess we've had the enterprise class guys like the Arubas and the Ruckuses and Cisco's. Yeah,
you got the Ubiquiti guys. You got them all.
The consumer class guys that are more for residential, maybe Soho. You've got the Netgears and what was previously Linksys, and then also became Cisco, and a few other guys, Belkin and such, and then.
And on the DAS side, it's the same way. It's different guys there too.
And now we're seeing this whole emergence of carrier class Wi-Fi with 211 AC and carrier class Wi-Fi. We've got Ericsson and Cisco and some other big players in that game. And then on the DAS side, DAS is a really healthy industry. I mean, it's from about 10 years ago. Everybody keeps saying, small cells came out and said, oh, what's that? How's that going to impact DAS? It seems like DAS, maybe it's reached its peak, but from where I sit, it just keeps growing. It's a very strong industry. There's quite a nice ecosystem there as well of a number of different vendors. Solid, being one. I'm sure you've got a few other competitors out there on the equipment side, and a lot of system integrators that are very important in that kind of deployment market, and all the major carriers, specifically AT&T being a big driver, on the DAS side. And then small cell, we have a really healthy ecosystem there as well. We've got, in small cell forum, we've got about 150 member companies, about 66 operators, about 77 vendor member companies, everybody from chips, Qualcomm, Broadcom, TI, all the way up through the access point providers like Spider Cloud and Cisco and IP Access and a number of others, test houses. I see somebody smiling over there. Tom, you don't want me to leave you out. Where do you fit in kind of middleware? Or, you got to talk to Tom. Raise your hand, Tom. If you need any help with small cells, there's your expert right there. So, no, it's quite a healthy ecosystem. And again, just like in the Wi-Fi space, you've got folks that are more focused on enterprise, folks that are looking at the consumer, residential play, and then you've got for the microcell or the outdoor market, the traditional infrastructure suppliers like Ericsson, Alcatel-Lucent, Huawei, ZTE, and those players there, Nokia as well. So next question we're going to talk about, which we sort of touched on a little bit, but we're going to talk a little bit about best practices. I know, Patrick, you're kind of touching into that, but you want to really dig in, maybe get to
Sure.
deployment experiences and best practices?
Sure. From a vendor's perspective, I think the key thing, the things we have learned deploying all the DAS in the last 5-7 years, mainly for a lot of large venues, really is to plan ahead, especially with the LTE added to the whole ecosystem for the network. There's a different aspect we're talking about planning. One thing is the nature of the DAS is a centralized RF signals in the base station hotels. You distributed the signals throughout multiple different signal sources via different sectors, but that's how the main RF source is one master head-end equipment room. One of the things what we have seen is all the large venues, it seems to be, there's upgrades every year just because either one vendor requires additional capacity, more carriers, or adding another frequency band. One of the things we wanted to do is, from a physical standpoint, you want to have enough room in the head-end room, and the carriers, you can bring in their RF source, Vs or base stations. You got enough room to accommodate that. And the second thing, I think, if you look at the practice, is from an engineering design perspective, it's always a good practice not to exceed the maximum power rating of any active components. You always want to leave some head-end room for something, just in case you want to add another carrier, another frequency, so you don't want to overdrive the system. And thirdly, I think this is really important because we've been talking about DAS as really a sweet spot for a lot of neutral-host multi-carrier system. It's the ability to accommodate different capacity requirements from different carriers. What I mean by that is, you got a certain venue. Operator 1 has capacity requirements of 10 sectors for that venue. And operator 2, you want 20 sectors. And operator 3, you want 30 sectors. This is all in the same venue. You want to be able to design the system or upgrade, if carriers want to upgrade different capacity. You don't want to touch the antennas or the cabling behind it. You want to do all the different upgrading, the mismatch, the matrix in the head end to master the equipment room. I think if that's part of the design process, and it's also very important because it's one of the things when you want to do the neutral host multi-carrier system, you want to see one antenna that you're transmitting AT&T signals or Verizon signals or T-Mobile or Sprint. That's from each one. They may be in different sectors, but that's what you mean by neutral host. And it doesn't make a lot of sense. You have 4 different parallel systems where you're changing every time you change a capacity. You want to change the antennas, you want to pull different cabling. So that's really important. You want to be able to do that. And
Derek, do you want to offer some perspectives on best practices from where you sit?
Yeah, I'm going to, we're at a kind of a crossroads right now, I think, with DAS a little bit in that maybe just for the next few quarters we'll have to see. But, usually, we have, 37 DAS locations that we're dealing with. And you end up getting the rights to the venue to say, okay, we're going to put in this DAS network. And you think most of our DAS nodes are about 2.8 carriers per DAS. We're a neutral host DAS operator. That's what our goal is. But one of the things that you realize that the cost of building a DAS network, and I know why the vendor guys like it, cost of building one that's perfectly planned out for all 4 carriers is 4 times the cost of just trying to build it out for one, right? And sometimes it takes a while for you to get, it's real easy usually to get one of the carriers involved. So in some locations you're going to get all 4 carriers, they're going to come in there and go, yeah, I want to be in there, let's get us in there and let's get all of them in there at once. In some locations you're going to get one, and it might take 6 to 12 months for their life cycle to sit there and get the next carrier in there, and then get the next carrier in there so that you get enough carriers in there. And in all in that time, as an operator, you're sitting there going, okay, how do I balance the cost, right? Because you used to operate underneath the idea of if you build it, they'll come mentality. So just build it all out for as much as you can. We're having to rethink that now. And we're right in the beginning of that rethinking mode. And I think what we've recognized is having to go back and look at how you're building out these DAS networks, sprinkling in small cells, sprinkling in Wi-Fi and all of these different things, is trying to sit there and go, okay, what is not the minimum that I need to do, but what is the smartest thing for me to do from that areas of what that location needs that's going to benefit both the venue that's helping you pay from some of the cost and yourself, and so that it ends up becoming monetary effective, this build out. So what I can say is this, I agree with the first thing is the backhaul, the running of the power, the running of the lines, all of that needs to get done because that's a huge part of the expense no matter what is that. Later on coming back and throwing a couple extra nodes on if you need to. You know, if they're not being used, to me that's where you got to start thinking about ways to cut back a little bit, is recognizing, hey, I can cut back on the nodes a little bit. I just build out the infrastructure behind the scenes so I'm ready once I'm going to get that second, that third, that fourth carrier on. And then the other thing is I agree that you need to have that room where you can put all the base station equipment, where it has all the power. You have to have that. So you need to start off first, I think, thinking really highly about the infrastructure now, and you got to think about all of that stuff. And then you start sitting there going, okay, now go back, and I sit there and go, how much can I get the carrier to carrier 1 to help me pay for carriers 2 and 3 who are going to come in later? How much are they willing to pay so that you don't sit there and carry this expense for a long time waiting for carrier 2, 3, 4, 5, whoever it's going to be. So there's kind of a shift going on now, and I think it's an important shift. And the nice thing is if you do throw in the Wi-Fi and you throw in a little bit of small cell in there, it ends up making it so that you've got an upgradable system for the future.
No, excellent. That's really good input. Thanks guys. So my last question for the panelists is my favorite question of the panel, and we've got Jeff Mucci from RCR is recording this, so we're going to bury this in a time capsule and dig this up in the magical year 2020 and see how close you guys are. But we're going to talk about the future. So, how cloudy is your crystal ball? So, who wants to go first? What's your vision of the future?
Well, I think that we've got to get to the point where a network's a network. It's really about just getting a network, and then we've got to, as we're all working towards, bridge this digital and this physical gap. Anybody who's ever heard me speak at other conferences, it's one of my big things. We've got a problem still with our networks today where we have this digital world happening and we're forgetting about the physical.